So 9.2a, elementary algebra, completing the square. All right, so completing the square is another method in order to find x. Up to this point, when you were given an equation, let's say you're trying to find out what x is, we have been doing things like x squared plus 4x plus 4 equals 0, and you come up with two binomials, and you find a number multiplied together give you 4, added together give you 4, and you put them here like that, and x equals -2 there, and x equals -2 there, and there's your answer. That's what we've been doing. Well, one of the things that you're going to discover in math, if you haven't already, is life is not always perfect. And there will be some problems that you get that you cannot solve that way. So, for example, x squared minus 4x plus 3 equals 0. Alright, two numbers multiplied together give you 3, added up give you -4. Well, 3 and 1, and if we make both of them negative, we just solved, so x is 3 and x is 1. Okay, so another one that worked just fine. Okay, what happens when you have, it's a pain when I make problems up and they happen to work, and they do the opposite of what I want them to do. So here's one that will not work. Okay, so we make a parentheses, put an x and an x. Two numbers multiplied together give me -2, added give me -5. Well, the only numbers that multiply together give me -2 are -2 and 1, or 2 and -1. And I can't add either one of those to get 5. So what do? You're like, oh, I'm done, it's impossible, the null set. But that isn't the case. There is another method that will always work, that you can always find the answer, and it's called completing the square. Alright, so in this particular lesson, what we're going to do is we're going to take any equation, whenever they ask you to complete the square, we are going to take any equation and turn it into a perfect trinomial. Remember, long time ago, we had a perfect trinomial, and a perfect trinomial, the way you can identify it is it looks like this, where this number is squared, that number is 3 squared, we can take the square root of it. So if we take the square root of that, square root of the 9, double it, we will get this number right there. Okay, that's how you can tell the perfect square binomial. Square root of the first term, square root of the last term, multiply those square roots together, double them, and get the middle term. Another example would be x squared minus 8x plus 16. Square root of that, square root of that, double it, and we get that. Okay? So those are perfect square trinomials. So what we're doing in this lesson is we're trying to make a perfect square trinomial so that we can quickly and easily find the answer. So if you're plugging along and you're doing your math and you come up with a trinomial like x squared plus 12x plus 36, and you're like, okay, I'm going to try to break it into two binomials, and that's the easiest way to solve this. But if this is not possible, if that doesn't work, then you have completing the square, which I'm going to show you today. So completing the square is your second option. There is a third option that we're going to learn later. So the first is two binomials, the second is completing the square, and the third is using what is called the quadratic formula. Okay, so those are three methods to solve for x when you're given a trinomial. This is the easiest, doesn't always work. This is a little bit more complicated, it always works. This is a little bit more complicated, always works. So these two always work, but this one is the easiest one. So you can kind of look at it and go, well, can I break it into two binomials? No, I can't. Oh, dang. So then you use one of these two. It doesn't matter which one of these two, but you're going to have to use one of these two. What you'll probably find is between completing the square and quadratic formula is the one you'd probably use because it's the easiest to remember. But completing the square, as you get into higher level math, there's a lot of good information you can get by completing the square, so it is important. All right, so how do I make a perfect trinomial? In this particular one, example 1, they give you that, and they're saying, all right, we need a third term here that will make that a perfect trinomial. Oops, there's a 14 there. All right, a perfect trinomial will always be half of that squared, and it'll always be a plus. There's your perfect trinomial. So when you're given just 2 bits of information, and in fact in the homework they do that to you, the first 18 problems, they give you the first part. So let's say, for instance, they give you x squared minus 6x plus, and then they give you a blank. The number that goes in here to make this expression a perfect trinomial is half the 6 squared. And there you go. You put your 9 there. Okay? And you're done with that. All right, if they give you one, I mean, they try to fool you, of course, and they give you something like x squared plus 2/3 x plus, what's that number? So the way that works, again, you take half of 2/3 and square it. All right, so let me give you a little bit of a clue as far as taking half of a fraction. Okay, I've never heard this taught. I learned this in high school when I was in architectural drafting, and taking half of something was always important. So the clue is, when you want to take half of a fraction, all you do is double the denominator, and you've just made it half. So 2/3, if we double the denominator, or when we don't do anything to the numerator, we get 2/6, which reduces to 1/3. So half of 2/3 is 1/3. Makes sense, right? Okay, what if I have 32/45? Half of that is 32/90. Just take half, or double the denominator, and you've just taken half of it. Okay, so that should make it real easy with completing the square when they throw these fractions at you. Just double the denominator and you're good. So double that denominator would be, like I said, 2/6, which reduces to 1/3. Then we square it, and that means we take that times itself and that times itself. So 1/9 goes there. So half of that and square it, and that gave us our 1/9 there. So let's keep plugging away here. So that's how you make an expression into a perfect trinomial. So let's look at another one. X squared plus 20 plus, it's always a plus. This sign here will always be a plus. Half of 20 is 10. Square it, and you're done. Okay. Let's do one more. Okay, so half of 5. You're like, holy cow, I don't know. Well, let's make it a fraction. 5/1, right? What did I say about taking half of a fraction? You double the denominator. That's half of 5. 5/2, or 2.5. And then we square it, which is 5 times 5 is 25. 2 times 2 is 4. There is your perfect square trinomial. Okay? All right. So this is example 4, and what we're going to do here is we're actually going to work through here and solve for x. All right, so first of all, we're going to do 2 binomials. And let's see, 2 numbers multiplied together that give me 3, added give me -4. Oh, dang. Okay, so I could do that. So -3 times -3 is +3. -3 plus Negative 1 is negative 4. So x equals 3 and x equals 1. Yay, it worked. I didn't have to complete the square, which is good. But let's complete the square. Let's do this exact same problem, but let's do it completing the square. Alright, so here are the steps. You get everything gone except the x's. So we have a positive 3 there, so we're going to move that 3 to the other side. I'm going to leave a space there. Okay, so we have nothing here as our third term anymore. We moved it. Because this is not a perfect square trinomial. And I know that because I can take the square root of this and get x, but I can't take the square root of that. So that tells me it's not a perfect square trinomial, so I can't solve it. So what I have to do is turn it into a perfect square trinomial, then I can solve it. So that's what I'm doing. So I put the 3 over here. Didn't really change anything here except I just moved this over to the other side of the equal. Alright, so what I'm looking for is I'm looking for this number right there that'll make it a perfect square trinomial. So remember how to do that? Take half of that and square it. Half of 4 is 2, square it is 4. Now this is a perfect square trinomial. But one of the things that you learned in algebra, hopefully, is that you can't just take x squared minus 4x and say it's equal to negative 3, and then over here just add 4 to it. Well, now it's no longer equal to negative 3. Okay, we just changed the value of this left side. Well, we can't just add 4 to this side unless we also add 4 to this side. So since we added the same amount here, in here, they're still equal. Okay, let that soak in a minute. You cannot add or subtract anything from one side without doing the exact same thing from the other side. And you've been doing this all along. Let's look at one. Okay, I want to get rid of this 2, right? So what did I do? I subtracted 2, but I also subtracted 2 over here. I did it to both sides. If I have x minus 6 equals 12, I add 6, I add 6. I do the same thing to both sides, and that's exactly what I did here in this step here. I looked for a number that was half of this and squared it and put it there, and I also put it over here. So I add it there, I add it there. Alright, let's see what we get. This is a perfect square trinomial. What is a perfect square trinomial? Square root of this, square root of this, and a minus sign here, whatever sign that is goes there, squared equals 1. Okay, see what I did? Go over it again real quick. When I get it into a perfect square trinomial, I take the square root of the first term, square root of the second term, and put this sign right here, right there, parentheses, a squared equals whatever negative 3 plus 4 is, and in this case, it's 1. Okay? Alright, so now we're still trying to find x, right? And this is what we have here. X minus 2, the quantity squared, minus 1. How do I get rid of an exponent of 2? Remember that? We did that a lot in the last chapter. You take the square root of both sides, and that gets a plus or minus. And then this all goes away, right? Okay, what is the square root of 1? 1. Plus or minus 1. So let's add 2 to both sides. So x equals the positive 1 plus 2, and x equals the negative 1, this part here, plus 2. So x equals 3, and x equals 1. Now when we did this using binomials, two binomials, it went a lot faster, didn't it? Well, completing the square takes longer, there's more room for mistakes, but it always works, and sometimes it's your only option. Alright, so that's it for this video, and we'll continue with 9.2 with example 5.